Good morning, and thank you all for coming here to the panel. Our next activity is this panel where we have three experts in diversity and promotion of minorities and underrepresented minorities in the STEM fields. And the way this is going to work, I'm going to introduce them first, and they will tell us a little bit about themselves and their careers. And then we will get back to the table and we'll ask them questions. I have a list of questions that I can ask them, and I will ask them some of those questions, but I really hope that it is you who ask most of the questions, and I will insist on that part, on you asking those questions. Before that, I would say that I'm really happy to be leading this panel and to be attending this conference. When I first joined IPAM, actually before I joined IPAM, when I was told that, when I was offered the position and I accepted it, the Latinos in Math conference was the first event that I attended. And now my term is almost up, and I'm here again in this conference, so really happy to spend this time in here. And also, before I introduce the panelists, I want to welcome into the conference a group of high school students from the local area who are joining this panel and other activities during the day. They are sitting on that side of the room, and we also hope to hear questions from you guys as you are the future. Okay? I will start introducing our panelists. Our first panelist is Talita Washington from Howard University. Talitha is an associate professor at Howard University in Washington, D.C. She got her undergraduate degree from Spelman College in Atlanta, I believe. And she's held positions at the University of Evansville and the College of New Rochelle, and has recently joined as an associate professor at Howard University. And since August 2017, she's been working with NSF. She's a program officer in the Division of Undergraduate Education with a focus on STEM education in Hispanic-serving institutions. Her interests are applications of differential equations in math biology. I will do the full introduction of all panelists, and then they will come up. Sorry about that. Our second panelist, Carlos Castillo-Chavez, comes from the University of Arizona, from Arizona State University, and he's a Regents Professor, Joaquin Bustos Jr. Professor of Mathematical Biology, and a distinguished sustainability scientist, and the founding director of the Simon A. Levin Mathematics and Computational Modeling Science Center at Arizona State University. Carlos was born in Mexico City and moved to the U.S. in 1974. He got all his degrees from the University of Wisconsin, from different campuses, and after 18 years at Cornell University in 2004, he moved to Arizona State University. He is well known from having mentored undergraduate students as well as graduate students and postdocs. His mentor 46 PhD students, 21 of them women, 26 from underrepresented minority groups, and 7 from Latin America. Welcome, Carlos. And our third panelist is Dagan Karp from Harvey Math College. He has an interest in algebraic geometry, but he's also the Vice Dean of Diversity at Harvey Math College, and he's done several. He's known for his efforts in promoting diversity and equality and inclusion. So please welcome Dagan. Talitha will let us know more about her background and career next.
Okay. So I titled this my STEM journey to justice because all the way throughout my life and what I've done, it's been wrapped around some sort of justice-seeking motif, even through the mathematical lens. And so I'm just going to, first off, I'm here as not representing NSF. I'm here under the guise as a Howard University faculty member. I feel that the Latin Math Conference is so important that I actually pay for my own plane ticket and housing and all of that out of my own pocket. And it's really good to be here. So I'm going to tell you a little bit about my story, my journey, and my life. I have a whole bunch of families, because it's probably because I'm a lot to maintain or groom. I don't know which, right? So on the upper left, that's me as a child there. And I was right here. This is my biological mother, and this is my biological father. They actually met in the Army when she was 19 years old. When she went back home to Indiana to my racist grandfather, he was like, get out. 8 months later, she put me up for adoption because she wanted a better life for me. So I was adopted by this family here, and here we are, a little bit more modern day, right? And so I grew up in a mixed race family, parents of German descent. So I have a lot of different cultures going on, okay? I graduated from high school a semester early and did a study abroad in Costa Rica, so I also have my Costa Rican family here. Yeah, so I just have a lot of family going on. So this just kind of gives you a pictorial view of all the different cultures and people that have really influenced and shaped my perspective. And then this is my half-biological brother. He's half native. Okay, so, for all my fantastic high school people in the room, this is my high school photo. The hair, I don't know, maybe a little similar. I'm trying to, calm it down. They used to call me light bulb head as a kid, but we won't talk about that. So this is me going to the Christmas dance as a sophomore. And when you're in high school, you're not thinking you're going to actually go off and do things. And you're also probably not thinking that whoever you go to the Christmas Tolo dance with will go off and do some things. So this guy right here is Philip Lawrence, and he kind of sings with Bruno Mars and writes his songs. So word of wisdom, watch who you date. Yeah. And so you never know, you have these young beginnings as a high school student. You never know that the person will actually grow up to be a mathematician, so never lose hope. So just a little bit more. After I graduated high school, after the study abroad in Costa Rica, I went to Spelman College, which is an African-American women's college in Atlanta, Georgia. Honestly, I didn't know it was all women. I think my mother snuck that on me because I was in Costa Rica having fun, We won't talk about that here, though. But so I worked in the grill because I needed money, right, down in Lower Manly. My first year, I was in the Morehouse Marching Band. Morehouse is right across the street, all males. The band was a great time. And this is our graduating class. The fall, when I actually came in as a first-year student, I said, I want to do another study abroad, and I want to study math in a Spanish-speaking country. I'm just coming off of Costa Rica, so I'm ready to go back to Central America. And my department chair said, no. And I was like, but wait, this is what I'm going to do. And she was like, no. A year later, when I was a sophomore, the chair changed, and the next chair said, I don't care what you do, go for it. So I ended up doing a fall semester in Mexico at Universidad Autónoma de Guadalajara, where I studied probability statistics and linear algebra 2, which was an interesting challenge because I never had one, and the professor had a speech impediment. I went from a 0 to 100 real quick, as they say. Yeah, talk about the struggle. But what I did was I corralled all the students in the room, all 4 of us, and was like, we're going to be best friends and go to the library and study like mad. So we had a great time. Here's a picture of me when I was an undergrad where I presented research in Science Day. Well, I'll back it up. When I was in Mexico, I got a call, and they inducted me into the scholarship program. I was like, that's cool. I'll deal with it when I get back, sort of thing. A part of the scholarship program, I had to do research during the academic year with the professor. Mind you, I had no aspirations of pursuing math. I was just using it as a simple vehicle. What do I mean by simple? I started out as an engineering major, but I said, that's too much of my life. I don't want to go to school for 5 years. So maybe I'll stay close to engineering, pick something that doesn't have a lab, because that's also too much of my life. So I chose the easy path of mathematics. Don't ask. Kind of twisted up here. So when I was in undergrad, my advisor, Jeffrey Amy, he worked with me a lot, and he forced me to apply to graduate school, and we also looked at researching stability of difference equations, which is still aligned with what I'm doing now as a researcher. I developed non-standard finite difference schemes, which was started here back in 1995, just a couple years ago. So you never know when you start these math as an undergraduate, as a high schooler, where that will take you later on in life. Well, so my advisor, he said you have to apply to grad school, and so I did. But then I kept hearing all these horror stories of people getting stressed out, dropping out, ending up on who knows what, that sort of thing. So I was like, grad school is intense. I applied to 3 graduate schools, I got into 1. That kind of simplified my choice, because why did I only have 1? I kind of didn't take it seriously. I had a job at Cigna in actuarial science, and I was going to be paid, okay? But I said, you know what, I'll go to graduate school, try it out, and if it doesn't work out, I'll be at UConn, and I can just hop on over to Hartford and go to Cigna if it doesn't work. But so to prepare, because, grad school can be stressful, and people who, the female mathematicians, they don't look too happy, right? So what I did was, I didn't have anything to do over the summer before grad school, so I did El Mundo Maya trip, where I traveled through southern Mexico, Belize, and Guatemala for 2 months by myself. That was a lot of fun. That was, kind of freaked out my mom, but it was a lot of fun. So while at the University of Connecticut, I studied under Dr. Youngzi Choi, and I looked at partial difference equations. I looked at a theoretical protein-protein interaction model. And I also had a co-advisor, McKenna, and interesting, when you go to grad school, you kind of pick an advisor who maps out what you're going to do, what you're going to study. And I kind of had a choice between the two. And McKenna, he was the one that solved the Tacoma-Narrows bridge problem mathematically. So I said, I want to ride the math biology bandwagon. But little did I know that much later, I would return to his work through my graduate student, who actually developed non-standard finite difference schemes for the Tacoma-Narrows bridge based off of his models. So you see how everything's just interconnected. Just, interesting. When I went to UConn, one of the niceties was there was a Spelman graduate from my undergrad, Dr. Lena Kimson-Price, who was there. And so I knew I had to make allies because it was hard. It was outside of my environment. It was Connecticut. It was when I walk in a room and talk with people, they're like, well, what country are you from? I'm like, I'm from Indiana. And then I kind of found out later that I was the first U.S. Black to enter into the PhD program. And so the expectation was not me as a PhD graduate student. So in 2001, I became the first U.S. Black to earn a PhD in mathematics from University of Connecticut. So, and so what is this whole PhD doctorate thing? So the idea for the PhD is you create something new. So you can almost think of the circle here as the body of knowledge. This is what we all know, all of us together. Because trust me, teenagers, y'all know more than we do. I have 3 teenagers, okay? So this is our body of knowledge, and we start off maybe in elementary school, we bump up, we go higher. And with the PhD, the goal is you want to add to the body of knowledge, contribute something that we don't know or we haven't uncovered yet. Sometimes it could be a small blip, but you never know. That small blip could actually turn into something really big. In order to get out of graduate school, my graduate advisor, Dr. Choi, said, you can get out if you get a postdoc. He told me this a week before the applications were due. Well, I just worked like crazy, got my applications out. My first job offer was a postdoc with Dr. Mike Reed, whose student I knew through a mentoring program. So in all honesty, when you go through postdocs, jobs, all the rest of that, it's by who you know and how they know you, right? So you got to tell people what you want in life because a lot of people will want to help you out. But as they say, along the way, life gets messy, reproduction, that sort of thing. So I had some babies. It happens, right? But it worked out. So after Duke, I was at the College of New Rochelle, which is in New York, which was what he said. And then New York was a little expensive. When I got to the point where I was paying for groceries on credit cards, I said, maybe I need to rethink my financial situation and location. So I went back to the Midwest and went to the University of Evansville, where I'm from, And I earned tenure there, and I just kind of ran into somebody at Howard at one of the joint meetings. They're like, you should apply to Howard. I'm like, no, dude, I'm almost done with tenure. Tenure is another big thing, another hurdle for faculty. And so, but after I got the tenure decision, I said, can I come and visit? Well, by the end of that same day, I had an offer for a visiting position. And so it worked out. I visited for a year, and in the year I visited, I was reviewed for tenure again. So it's kind of like a back-to-back tenure fiasco. But it was fun when it was done. So just a little bit about my work in diversifying our STEM talent. You know, they always say you got to start with home, right? So these are two of my kids. Like Carlos said, I think my son was too tall to fit on the slides. He's like 6'4", so, you know, funny. He's 6'4" and he's 16. But so this is my oldest kid. She's actually a first-year student at Howard University. She's in computer science, majoring in computer science. She's in 9th grade. She's in the Biosciences Academy at her high school. And then my son, the 6'4" guy, he's in the Engineering Sciences Academy. So I like to share my work and what I do with my kids. And when they come to my class, usually they fall asleep, but they're still there, and then I bribe them with food to come and be engaged. Yeah, you gotta do what you gotta do. And so I think it's by no accident they chose somewhere in STEM to kind of pursue. So here would be the year that I earned a PhD in mathematics. So note here, so this is data that one of the math societies collects. And so the year that I earned a PhD, just to kind of give you an idea about the numbers, so there were 960 total in our country, and only 6 of those were Black females, and only 2 were Hispanic US females. So underrepresentation, I mean, yeah, that's a problem. And that's a problem that we still face. That's why we really need you all here today and contribute. And here's an interesting report from the National Science Foundation, 2010. The reason why I like this is because you can look at the 2 pies. The pie on the left is the total US population. The pie on the right is those in US science and engineering. So if we look at the pie on the left, Hispanic females, this is 2010, so these percentages may be different today, okay? But Hispanic females is 8.1%. But if we look at Hispanic females in STEM, it's only 2%. Hispanic males, 8.3%, but in STEM, 4%. This is what we call underrepresentation. If we look at Asian females, 2.5% in the population, however, 5% double. Asian males, 2.2%, 13%. This is what we call overrepresentation. So something is not right in the mapping of the US population onto those who are in STEM, because it's people that drive it, and we know our country is becoming more diverse. And if we don't have these pie charts looking a little bit more similar, we're gonna be in trouble as a country. Here's another chart. This is minorities earning science and engineering baccalaureate degrees. So this is undergrad, college degrees at minority-serving institutions. Now, this is a trend line going from 2004 to 2014. And on this axis here, we have the percentages. Now, HHE, that's institutions with high Hispanic enrollment. 25% of the undergraduate population are Hispanic. Note the decline here, and that's troublesome. At the historically Black colleges and universities, we were also experiencing a decline. So, yeah, and then this is very small. These declines here, to me, are troubling. Something is not right there. So I'm giving you a piece of what's on my mind and what keeps me up at night. Here we have, this is a graph of Black doctorate recipients with baccalaureate degrees from historically Black colleges and universities. So even though 9% of our nation's institutions are HBCUs, they account for 30% of those earning PhDs. And if that decline keeps going down, that's a problem. Similarly for HHEs. Note that for mathematics, we're at about 38%. 38% of PhDs came from HBCUs. When I go to conferences, most people come from an HBCU if they're Black. It's kind of one of those things, it's an expectation. So here's a colleague of mine, this is Vernon Morris. We wrote an article recently that was published in the February edition of the Notices on the role of the professional societies in STEM diversity. And one of the things we grappled with is the younger generation versus the older generation, and how do you work the two, and what are the two experiences? So we think about this in segregation era versus post-segregation era. So if you're a younger person coming into STEM, you grew up with a black president, this is pre-Trump, okay? You grew up with a black president and everything, things were okay, so to speak. And then we have the racial climate of today. Have we really trained our young people on how to handle those sorts of situations? And this is something that we've been grappling with. And then also many believe in the meritocracy myth. If I'm good enough, I'm gonna get it. There's also that subjective undercurrent that sometimes we don't see. And it has nothing to do with us, it has everything to do with how other people view things in their lens. The battle over racism may be foreign, and hence we worry that the young people will be ill-equipped to deal with the hostile racial environments in STEM. So part of my mission is also to kind of take that head on, and how can we bridge the divides and lower the barriers and enhance the communication. So one of the questions is, what must a modern scientist of color do to persist in a STEM career? So one thing I always say is to be aware of images, and at the same time create your own image. Because oftentimes you won't see yourself in the position that you want to be in. So you just have to create it yourself. On the lower left is a cartoon that kind of went around. It was, wow, you suck at math, wow, girls suck at math. The imagery of females in STEM. And then on the upper right, this was one of those posters where the females were associated with applied math fields and the males were pure math fields. So we have to be careful about the imageries, and we have to be careful about we just need to create your own image. Who do you want to be? How do you want to be? And have your choices aligned with those. Oftentimes at the professional societies, if you're a person of color, you kind of get slated as being the help or the service or other than mathematician status. And this can also be some mixed messages that I think have an impact here. So this is Ron Mickens. I've known him since I was an undergrad. I do a lot of work with him on the non-standard finite difference games. And we were at a conference, this old lady asked him, where can I park my scooter? And he was like, anywhere you want. And we're like, well, why did she ask you where to park the scooter? And he said, and somebody else said, maybe it's because you're wearing black. He said, no, it's because I am black. And then this was posted on Facebook, and there was a lot of comments where people expressed that they had experienced these overt comments when we walk into STEM professional societies. So one of the things walking into STEM, you just have to be aware it's not you. It's just other people, and they need better imagery. So where do we go from here? Here are just 4 things I'd like to express. First, to act. Apathy is acceptance. So we have to take action. This has to be done through a collective. And also to speak up. Even when you think it's not cool, even when you think it could be risky, to speak up. Draw people into conversation. Have a conversation, not the divide. Also to pressure leadership. Assist, prod, and provide solutions. Oftentimes we like to say what's wrong without saying, well, how can we move forward? What are some palatable solutions where we can all benefit? And to stay engaged. Persistence yields results, so to stay at it. And that's why I have this here. Oftentimes you try, you fail, try, fail, and you're kind of in the cycle, but eventually you flip to success. So how have I kind of carried this out with some of the things that I do? Well, back when I was in Evansville, see, that's me right there? See? One of the 6 people you need to know with the bishop. Poor bishop. And you all familiar with Project Lead the Way? That's the head guy of Project Lead the Way, Vince Bertram. Yeah, he's like the CEO, right. So they do a lot of the science and engineering in the high school curriculum. So, this is me here. This is Elbert Frank Cox. He's the first black in the world to earn a PhD in math from the same neighborhood, but I didn't know that until I was a grown-up. I was also involved in bringing EDGE which is Enhancing Diversity in Graduate Education, to Howard University. So we host students and we have fun. Look, everybody looks like they're having fun doing math. This is with me, with a police officer. No, I'm not getting arrested. I went on a ride with an officer because we were looking at data and how the police force was using data. How could data inform how police make decisions? And actually, that was at ISTORM. That, for me, was a very tough workshop because I was the only U.S. minority in the room. And growing up, the police and the stories and the violence is very close. But we need people at the table looking at this idea of data science and the intersection with police and help them make better decisions. Because if we're not doing it, somebody else will, and that may not be a good look. And here, this is me at Park City Math Institute. And so when you're a mathematician, you can go to conferences and they feed you. There's my food. And you could just learn math and do data science. And at this institute, there were 2 hot tubs and 3 weeks of data science. It was fantastic. Love it. As a parent, I'm a math mom, I recognized that STEM camps were very expensive and I couldn't afford them. So what did I do? I ran my own STEM camp for my kids and then other kids to join in. So that's what this screenshot is from. And then I also coached my kids in their basketball and soccer. Here is my PhD student who just defended this past December. He's now at JP Morgan Chase, and he's doing deep learning with cybersecurity. Probably making, quadruple my salary? But yeah, he's having a good time. I'm also involved with a lot of the professional societies. Here I am with the National Association of Mathematicians, where I was vice president. Here is me at the Mathematical Association of America, where I was on the Congress. And here I'm with the student group with the Association for Women in Mathematics. You gotta have these awkward selfies with Ken Ribbett, the president of American Mathematical Society, and Terrence Blackman. So I'm on the council there. I think I'm number 5 African-American to be on the council. And then here, with the SOCNUS, I did their Summer Leadership Institute, advanced and the regular one. Fantastic experience. And then since August, I've been a program officer at the National Science Foundation, where I'm a co-lead in the Hispanic Serving Institutions program. And that's been a really fun experience in helping define that and to help us meet the needs of the community. Because there's a lot of STEM mysteries that we need to solve. We have data science, where does life come from? We have things melting on the extremes of the Earth, what's in outer space, genetic discovery. There's a lot of unanswered questions that can be solved with STEM. And there's a lot to do. And so, I encourage you young people to stay with it and help us figure some of this out. If you ever end up in a room where you kind of feel like you're the other, you're kind of singled out, make sure you raise your hand and be assertive. Even when you're in that meeting, be assertive and state your presence. And I just want to leave with this imagery. All of these females here are mathematicians, and it's a journey. And it's a journey that we all do together as a community, which I think is the best part. I get to see people over and over again, and everybody's been super fantastic and helpful. So with that, I just thank you for having me here and giving me the opportunity to share my journey.
Thank you, Talita. Carlos, Dagan, please.
Thanks very much, everyone. I can't tell you how stoked I am to be here. I really feel unworthy. Dr. T-Dubs, Carlos Castillo-Chavez, this is legendary stuff. Can we just please give them a little bit more praise? These folks have been changing lives since forever, and I think I just want to start with apologizing. I apologize for not in advance planning to have maybe a sign interpreter, or for talking about captions. There might be people here that have reduced hearing or are deaf. I didn't do anything about that. Also, I knew I was coming to this conference, and I knew that I might have the opportunity to do something like this, and I didn't talk to the organizers about maybe having a map of all the gender-neutral bathrooms in this facility or in the other facilities that we're using. And so I bring this up to point out that I am in the process of constantly doing critical self-examination so that I can improve how do I think about our journey towards social justice? There is a social responsibility that we have to each other, and that also mandates an internal looking, critical self-examination that is lifelong. This is not something where we think, we now have justice, let's chill, everything's good, we can put our feet up. It will be a lifelong journey for all of us that will never end. We can only hope to move slightly more in the direction of justice. And these are big ideas, but they're also incredibly real to the folks in this room and the folks that are supporting us being in this room. There are people that will clean the floors that we're sitting and standing on tonight, folks that are cleaning the bathrooms and the toilets that we use. And I ask myself the question, what are the odds that their family, that their children will get to be a professor of mathematics? And is that different than the odds for somebody who is, say, an administrator at a place like UCLA? And so this is something real, and I think about this as a human endeavor, as a family. And let me give you a couple different perspectives. One, a very scientific from a biological perspective. There's a celebrated biologist named E.O. Wilson that spent his life studying ants. And at the end of his career, he wrote a trilogy of books attempting to explain the human condition from the biology that he learned studying ants. And the big short story that he came up with is that the reason that eusocial species, highly social species like humans and some ants and bees, the reason that they're able to be so successful is because they can decide to be on the same team. If you take Argentine ants that are separated by 5,000 miles, far farther than they would ever walk in their lifetime, and get them to hang out together, they're like, what's up, we're on the same team, no problem. If you take an Argentine ant and another ant, they will fight to the death. So they're able to be successful because they're on the same team. And let me give you maybe another more spiritual perspective that I learned from Rochelle Gutierrez, where we're thinking about this as a human family in the sense that we have deep interpersonal connections. And maybe the Mayan term in Lakesh is appropriate. When I see you, I see myself in you. I am the other you, and you are the other me. I think that this is a more spiritual way of expressing the same sentiment of us being all brothers and sisters, somos hermanas. We're all together in the same family. And so I want to think a little bit about where we are right now and how academic institutions function. So we're at UCLA. I don't want to pick on UCLA. In fact, I have a lot of love for this place, for IPAM and for UCLA. But sometimes we think that these academic institutions just kind of arose naturally, that the gods deposited them, that Tezcatlipoca, the Aztec god of the night sky, somehow just blew UCLA onto the shores. Of course not. This is a very human endeavor, and folks did this, and there's actually a mission. I don't know if you have ever looked up the mission of UCLA and what we're supposed to be doing here. The mission of UCLA's primary, I printed this out, UCLA's primary purpose as a public research university is the creation, dissemination, preservation, and application of our knowledge for the betterment of our global society. Not to produce knowledge for its own sake, not to disseminate knowledge for its own sake, but specifically for the benefit of our global society. They go on to say that in all of our pursuits, we strive at once for excellence and diversity. That's worth examining a little bit. And they go on to say that UCLA creates an university enriched by diverse perspectives where all individuals can flourish. Okay, so let's think about this just briefly for a minute. Let's think about excellence and diversity and situate this in our local context. Maybe folks know a little bit about the Los Angeles area. What percentage of the county of Los Angeles it consists of people who self-identify as Black, African American? Does anybody know? So roughly 10%. It's pretty similar to the overall US population. But the homeless population in Los Angeles is over 40%. Talk about overrepresentation, Dr. T-Dubs. This is exactly the type of thing that we're looking at. And similarly, should we compare the LAUSD, over half of which self-identifies as Latin American, Latinx, Latino, Latina. But should we compare that to the population in Twin Towers Correctional Facility, downtown Los Angeles? And maybe we should compare that to UCLA Department of Mathematics. There's over 90 tenure and tenure track professors of mathematics at UCLA. I'll let you do some Googling and see if you can determine how many folks might self-identify as Latinx or African American in that department. These are not separate. These are not separate. This is the same problem. These are interconnected. There's not an accident that power and wealth create systems of oppressions and that there's underrepresentation in mathematics just the same as in other parts of society. And I think it's also worth focusing on this phrase can. UCLA creates an environment where all people can flourish. I think this is one of our biggest jobs as mathematicians, to point out the difference between probability and possibility. According to quantum dynamics, it is theoretically possible for me to walk through the wall right now. Same for you. The distance between the nucleus and the electrons is very big. We're mostly empty space. We could walk through the walls right now. Congratulations, you're all superheroes. It's possible for you to walk through walls. Congratulations. Of course, that makes no difference. We bet our lives all the time that that will not happen, that I won't fall through the floor. So that something is theoretically possible is meaningless. We're looking for equal probability, not just the existence of a possibility. Okay, so what should we do? We have this work to do. We see inequities in our discipline. How should we begin? Whether we're graduate students, faculty members, what should we do? We don't have to reinvent the wheel. Luckily, there are people already doing the work and people thinking about the theoretical foundations of our discipline, people studying our discipline. We just have to avail ourselves of the knowledge that's created. Carlos Castillo-Chavez has been doing this since before I was born. Rochelle Gutierrez is teaching us every day. We just need to look at their work. So how do I think about this? Let me conclude with some thoughts about the discipline. What we need to do, in my opinion, is to transform mathematics from a subject which creates and exacerbates societal oppression and systems of inequality, fundamentally restructure the discipline into one which is specifically anti-oppressive. So let's think for a minute. What is anti-racist linear algebra? Right? We're not doing linear algebra for no reason. We're doing it for the benefit of the global society. What is anti-misogynist calculus? Tell me about the anti-transphobic Langland program. Right, where do we see this arise? And so Rochelle Gutierrez and Danny Martin and Luis Leiva and Nicole Josephs, people in math education are theorizing and giving us groundwork and research-based practices to move in these directions, thinking about rehumanization, decolonization of our field. And I like to think about the queering of our field to bring in terminology from our peers in the humanities, social sciences, critical theory. The idea is to transform in an ongoing way so that this is not a stable state that we're looking for, but a constant state of redefining and re-articulating what it means to work for a transformative mathematical practice. So let me just stop there. Thank you so much.
Now that my age has been disclosed, I want to. I'm delighted to be here. Thanks to the organizers and that did this. But thank you very much to the high school students for being here. Over the last 2 years, I spent my time mostly in Colombia and Ecuador, and last 3 months before I returned to the States, I traveled about 1,500 miles and visited 9 states in Ecuador and talked to about 4,000 students. And the worst off by far in Ecuador and Colombia, they were all Afro-Latinos. That's absolutely the worst situation that I have seen. So the struggle, as was pointed out before, is really a universal struggle. So I'm going to tell you a little bit about where I come from. I come from the Mexican Revolution. So this is my great uncle, Marcelino Castillo. And he actually didn't have a last name, but his brother, which was about 25 years older than him, that was my grandfather, didn't have a last name. So I assumed he was Otomi. So he chose Castillo. So in this town near where Sor Juan Inés de la Cruz was born. There is a lot of Castillos, and I don't know who is who. They didn't used to acknowledge me as a relative. Now they do. So who knows? This is my dad. He was in the military. And like many young people, he left after high school, which actually middle school at that time was 9th grade. I had an argument with his father and joined the military. That might sound familiar to some of them, and that's the way he eventually became educated. And this is my mom, like Alandra Tapia. She's from Jalisco. She might have finished 3rd grade, I'm not sure. An incredible singer. So when there is mariachi music, I go absolutely crazy because since I remember, she probably sang 20 songs every day at least. Anyway, she lives in Mexico City. That's the only parent left, and now I take care of him. This is some of my relatives. You can see me and my brother there, which also passed away. Most of my brothers have disappeared now, fortunately. And these are my uncles. And all of them work in the States. My grandparents work on the States. Everybody crossed the border and were migrant workers of one kind of another. That was when there was one Mexico. Now I'm waiting for the wall so we can tear it down. And it also acknowledges something that has sometimes not been acknowledged very clearly, and as an immigrant, I'm very aware of that, is if there is a group that is having a hard time, is the group of the dreamers. And they are Mexicans. They are Mexicans, many Central Americans. I just gave a commencement speech at the University of Wisconsin at Stevens Point, Wisconsin, which is a very Republican state, and it was a celebration. And if you want to look at me in YouTube, because I managed to convey that message, and over the next 24 hours, there were about 5,000 parents and children, I actually was acclaimed by the people that were there, because once you explain what is the situation that the dreamers are on, all these ideas of culture, of identity, and things like that disappear. And who was first, and who was second, and who is a youth Latino, and who is not a youth Latino. So that's very important. And the defeat that for undocumented students at Cal Halden High School in Phoenix, Arizona, where they beat in an engineering project several universities, University of California, Santa Barbara, I think some school nearby here, and MIT and others, highlight that being a great engineer is not enough to get you admitted in any engineering school. And that seems to be ignored. Fortunately, there's a documentary that was done to do that, but that's still ignored. Even after they defeated them in an engineering project, none of them would have been admitted at any of these engineering schools. And only one of them finished college. This is my children, and since I have moved economic and so forth, they are doing well. My daughter was just at Harvard. She's studying at CUNY. She's studying Afro-Latino. She's an activist. My son is a professor of math education. And this is my now 19-year-old, Gabriela, who has been in the hospital for 6 weeks. On her 15th celebration. So let me go where I started, which is with my great uncle. This is where I come from. And the next thing is, where do I go from here? And I had no idea, and I think I still don't have any idea. And that's anybody that has followed what I do is I just go and change with the times. So I wanted to be a musician, good for music that I wasn't. A hotel manager, I wanted to be one of the managers of some of the biggest hotels. Actor, mathematician, you name it. Growing in Mexico City was complicated because even though we are so intimately connected, we don't know a lot about each other in many ways. So there was the 1960 student movement in Mexico with millions march. Everybody talks about the movement in France and everything. In Mexico was bigger. And there was no democracy in Mexico. And in fact, the first pseudo-democratic elections in Mexico were in 1997. A lot of people think that, these things are okay. And during that time, I was in high school, I used to go to all the political demonstrations, and I missed that one. And the army came and killed thousands of students. So that changed my life. And then I became involved in what one would consider today community theater, trying to portray the situations to theater. We tried to put some plays. Some of them were okay. Some of them the government stopped and work. Hotels, selling cokes. In 1974, I immigrated to the United States, Wisconsin. I worked in a cheese factory. And I applied to UW-Stevens Point because they accepted everybody, and they didn't make an exception with me. And then I studied mostly literature, and then some mathematics. And I worked various jobs, dishwasher, outward bound. And there was a second critical point in my life when I was lacking $400 to graduate. And I ran into Lee Dreyfus, Chancellor, later governor, who now passed away. And he came back from China. He was telling all the stories because nobody was really expecting him to return. Took me to his office, and after I had to listen about China for about half an hour, he told me, "What do you need?" And I said, "It's $400 to graduate." He said, "Sure, no problem." Picks up the phone, and they tell them, "We are tired of having this guy in this office asking for a loan. We can't do it." And I said, "I'm the chancellor. You do it." I write the letters. And that allowed me to graduate. At school, it's interesting in the States. I learned about my culture. I studied literature, so I studied Cervantes, and I studied Garcia Marquez, and I studied Carlos Fuentes. And I also became familiar with the history of the United States in Cesar Chavez, which I met later on at Cornell, and many other people. Getting educated is really important, and not losing the connection with our roots is critical, absolutely critical. I applied to grad school. Everybody rejected me. I think Rodrigo was here. And then, so I went to the University of Wisconsin-Milwaukee, and that's the only one accepted me. And then suddenly I became a very good student. Before I had C's in statistics, guys. Don't do that. And later on, I was the chair of, and one of the founders of the Department of Statistics at Cornell. I was chair of biometry. And when I told them I got a C in statistics and my GREs weren't great, they didn't believe me. They wanted to believe that since I was doing fine, that I had to have the trajectory that they had, that it was impossible to come any other way. So then I had a third critical point. I chose as advisor the best mathematician there. Was doing state theory. I was doing in that. And then he asked me to go out to dinner, and we had never really talked. He went to classes, gave his classes, left. You had to make an appointment. And then he had invited his best student to give a talk, and he wanted me to have dinner. So I was very excited. Took him to a Mexican restaurant on the south side of Milwaukee, and I didn't say much. And towards the end of the day, he talks about a memo that had appeared at that point, and I think Rodrigo mentions being children of affirmative action, and that was a memo in Milwaukee about affirmative action. And nobody really had paid too much attention, and he said, "You notice that they only talk about Hispanics, we were called, we changed all the time, now it's Latinx. African Americans, I think it was blacks at the time, and Native Americans, but they don't mention Asians." And then he said, "Do you know why they don't mention Asians?" He had the answer. He said, "Because Asians can do it on their own." That was my PhD advisor. So people were upset I didn't say anything, which was the first time, and after 1968, and remember where I came from, I felt very embarrassed about myself. So I went to my home in tears, and when I came back the next day, I asked to be changed of advisors, and he wouldn't. And people tried to help me, and we couldn't. It was 1976, so I quit and went to work. And then a bunch of people told me, "No, you have to continue," and they helped me. And later on, I applied to schools, and every school accepted me, but I was in love, and still in love. Just probably as Rodrigo is with UCLA, I was in love and wanted always to go to the University of Wisconsin-Madison, primarily because of Walter Rudin, which was in the same field as Rodrigo. So I attended graduate school, and then I did my thesis before I took my qualifiers, so I would not be embarrassed. That was the best thing that I could possibly do. So they say, well, you need to take qualifying so you can prove you can do math. I said, I have some results. You still have to take it, but that seemed to me a contradiction. It didn't work. I had to take them anyway. And then after that, I took a postdoctoral position, and I had the chance to go to do math or biology. And since I never know what to do, biology. So I went to Cornell. And after 3 years there, Harvard offered me a position. And then after Harvard offered me a position, everybody offered me a position, including Cornell. They offered me 2 jobs. And I decided to stay at Cornell. Did I do this by myself? No, never. They say, do I have a single mentor? No, many. So here is Gilbert Walter. He didn't let me quit. Fred Brown, my PhD advisor, he's 86. He still helps me with my summer programs. We're finishing our 2nd book. Simon Levine, my postdoctoral mentor, now got the National Medal of Science. And we named my center after him because he has been such a support of diversity everywhere, women, interdisciplinary science, and so forth. Did I meet Latinos? No, but I knew who they were. I used to be a book by David Sanchez on differential equations. I used to carry it just to see Latinos can do math. I never took a course in differential equations, which is interesting. And then we had the great Richard Tapia. And that's when he won the National Medal of Science. I was in the National Medal of Science Committee. And Bill Bellis. And a couple of years ago, I was the recipient of the first Jackie Pasqua Bill Bellis Award. And the Jackies are an interesting thing because it reflects the best of us. They live in both sides of the borders. They don't worry about politics of identity and who's Mexican and Mexican-American. And they're being divided by a wall. And when the Jackies on this side of the border, they want to prove that they are Jackies, they had to go to Mexico to get the paperwork to prove it. And then there's the Blackwell Tapia, Blackwell, one of the giants. So these are all the Blackwell Awards that we have had, starting with Arlie Peters, Rodrigo Bañuelas, Bill Massey, Juan Mesa, Tachet Jackson, Ricardo Cortez, Jacqueline Hughes, and Mariel Vasquez, and many women of color in this list. Other mentors, Wesley Harris, which is my connection with Martin Luther King at MIT. I spent some time there, right? And James Sylvester Gates, also National Medal of Science recipient. There I'm with Richard Tapia also, there in the White House. And he was also Bill Gates. My research is a stream of continually shifting projects driven by social concerns. And where do they come from? From my students. I have a summer program that started at the instigation of Bill Bellis in 1995, started in 1996. It is since 22 years. It graduated the first PhD that came through the program in 2003. And through 2006 until now, it has graduated 143 PhDs. About 70% students of color, 90 underrepresented minorities. We just graduated the 150 PhDs that came from that program. And you want to see Latinos that are doing math biology, most of them went through this program. Absolutely, the overwhelming number. Thank you. But we have created a program that is diverse. We bring international students from Latin America. I have done this program in Mexico at UNAM jointly. So we try to make international, because science is international. You can't think of this in doing science and ignoring any part of the world. But it has been deliberately to attract students from small colleges and universities that come from underrepresented US groups. And my research is in many areas, all guided by the ideas of them. This is the first class of 1996. I had 36 students. Cornell at that time had an RU for the whole university of 40 students, and I didn't know. And they get a lot more resources than I did because I didn't know. Otherwise, I would have said, come on. Most of these people now are PhDs. Many of them are faculty at various universities. Many of them are here. This is one of the groups that I have here. Sara del Valle is here, for example, that came with me. When I came to Los Alamos, that's the first year that a Spanish-speaking center has been born. It's interested, it's in New Mexico, where great people. And at Los Alamos, there are almost no Latino scientists, but when I was there, we made the difference. All of these people have finished their PhDs. My research comes from applications, since Ronald Ross, medical doctor, Nobel laureate in malaria. So he wins the Nobel laureate, and now he wants not to control malaria just for his community, but for the world. So he has an idea. So he discovers some phenomena, gets a Nobel laureate, and then now my interest is the public good, talk about social justice, and this is a problem and challenges across scales, how what I know at some particular level, I can expand at higher levels of organization. And he had an idea. He said, we have to reduce the mosquito population below some threshold. They didn't believe him, so he brought in mathematics. In a beautiful 1911 paper, put in mathematics as an appendix, where he shows that, in fact, if you do that, you can control vectors. Now they believe him. And in that same paper, he writes, these models can be used to study sexually transmitted diseases and so on. And those study the basis of the models for sexually transmitted diseases and later HIV. Let me see how's that. So these are some of the questions. If you want to be in the questions, I never took differential equations, so I still don't know what they mean. And this is the work that he did to win the Nobel Prize. So it's very interesting that once you know what are the mechanisms of disease transmission, the next question is, how do I use this knowledge to help my community, to help my state, to help the country, to help the world? That's what scientists do. And in this was a first mechanistic model where you could see the host vector ratio, biting rates, and nobody has really been using those things, and he did all this by himself. A medical doctor that said, if I want my field to be of help to the world, I have to scale up what I do, and that comes with mathematics. This is Sara del Valle, which might be here. I don't know if she's here. Yeah, you're here. And she went through University of Iowa. We have had about 10, 12 students graduating from University of Iowa that came from a program, about 20 from Cornell, about now close to 50 from Arizona State. And she works on doing these simulations and more to study the spread of infectious diseases, not only in cities, but across the world, air transportation. She has a big group of research, and she was telling me today that her research group has 60% women at Los Alamos National Laboratory, and when she came with me, she was a graduate student in Iowa, and she said, Carlos, I know you're going to Los Alamos. Can you take me? And I said, I always say yes, so of course come with me. And there she is now. And these models have been used to study the spread of influenza. One of the big challenges is how come the decisions that people made, the changes of behavior. I just came from Ohio, where we had a conference about that. How the changes of behavior affect that. As people change and their decisions, how do they do them? How do you model that? They change the landscape where things take place. And as they change the social and environmental landscape where the diseases spread, how does that change the dynamics of disease? How do we use that? How we study biological systems as complex adaptive systems. And this is an example. The left side here is an epidemic of influenza where nobody changes their behavior. Everybody kisses each other, like Latino land. And in this case, they said, let's postpone it for a week while the influenza epidemic goes by. And we see a different situation. Okay, let me see if I go. This is the first class, as I said. Many people that are here were participated. I worked for President Obama for several years, 5, 6 years. And then he also gave us a mentoring award. I have a high school program that is in honor of Joaquin Bustos, Jr. He was the first Latino to get a PhD from Arizona State, an Arizonian. The second one was 1997, and when I arrived in 2007, there weren't any. Last year, there were 7 that getting their PhD in the mathematical sciences. So thank you very much, and thank you very much, guys, for coming here.
Thank you very much to the three of you for sharing your life experiences and your vision and perspectives. We still have some time for questions. And just as an icebreaker, I'm going to start with those questions, but I truly hope that some of you will raise and ask questions. We'd like to actually hear from all groups represented here. We have a microphone here, and I'll be very happy to bring it to you, or Stacy will bring it to you, or you can just step up and use it. And if we can have questions from each one of the groups that we have represented here, including this group of high school students, undergraduates, graduates, please come up and ask questions, because I'm sure that regardless of all these beautiful experiences that they have narrated, there are still things that they can tell us that can inform all of you in how to pursue careers in STEM science. So since we have first question coming up, I will save mine, and please go ahead.
First of all, thank you very much for sharing your experiences. I'm sorry, I'm getting a little emotional. I just want to ask you, where did you find the strength to keep going when you feel the pressure? I have seen it in a lot of us. The struggle is not easy, and I just, you made it, right? And this is inspiring, and I just want to know what kept you going. Thank you.
Hello.
So I know I was talking with someone earlier that when I went through the tenure track process, I did a lot of kickboxing. So when I was in graduate school, I was stressed out. I had tension T. Won't tell you what else I had. But one of my colleagues was like, you know what, you need to exercise and calm down. I said, okay, I'll try that. So and I did it, and I'm an exercise junkie. If you look at my webpage, I'm doing a one-arm burpee, but that's another story. So I'm open. When I need help, I'm not afraid to ask for help. I don't need to do everything on my own, because I find that when I ask other people for help, they get something out of it, as do I. And so by asking help, I give them an opportunity to be useful, to be open, to share. And it's a mutually beneficial ask. So I'm not afraid to ask for help. When having 3 kids, I was like, oh my gosh, what is this? I got a doula for each child. They're a professional labor support person, because I was like, I cannot do this on my own. And I also went to La Leche League meetings where people would sit around in a circle and talk about their lives. I was like, your life is worse than mine. I feel better now, So being open to ask for help, to say, I'm going through this, but you have to do it with specific people. I'm going through this. How do I make it through? I see that you're doing this. How did you do it? Asking people questions. I did it all the way through high school. I mean, when I was in high school, I know who sold drugs. I know who was doing the street fights. We ran from bullets, that sort of thing. I'm kind of from the hood. So I also looked at the choices people made and where they ended up. And I said, you know what? There are certain choices that this person makes. That's where I want to go with my life. And then how do you do it? Can you give me some insight? I'm trying to figure this out. How am I doing it? When I came to NSF, I was like, oh my gosh, what is going on? I don't even, I was up to here, right? And so I called a friend of mine. I was like, I don't know what I'm doing. He was like, you think it's a 40-hour-a-week job? I don't think so. And so he was able to frame how I can think about the situation so I can function better. So sometimes it just takes another person to help frame your situation, to say, here are things you can do to make it through. And it's not you, it's just how it is. And so I ask for help all the time.
Okay. Just is very simple. My reason shifts at this moment is the dreamers. I can't put myself in their shoes. I consider myself incredibly lucky. When I look at each one of us every day, it breaks my heart and it makes me angry. So instead of that, I try to do that in a positive thing. It's the dreamers has been what is driving me right now.
Okay. Before you ask your question, can you tell us your name and where you come from?
I'm Alex Rodriguez. I'm from Latinx Mathematics Science Technology Academy.
Great. Thank you very much. And what is your question?
Since many freshmen have difficulty with mathematics, did any of you have difficulty in math when you first started out?
The lowest grade I received as an undergraduate student was in linear algebra. I got a D in linear algebra. This semester, I'm teaching linear algebra. So don't be too bummed out. There's lots of bumps in the road. Don't sweat it.
So when I went into college, I tested in pre-cal 2, and I was like, how can I test in pre-cal 2 when I did calculus? So I was like, okay, fine, whatever, And I remember my second year, we took, in geometry class, you do the proof, right? And then it's kind of challenging to write the proofs and make it all logical and stuff. So when I took that proof and problem solving class, I said, well, the first time around when I took it, let me back it up, I got a W. That's a withdrawal. Because I was like, I am in over my head. I'm pulling out of this. That was my first year. My second year, I was like, okay, I'm going to do this. I stressed out. I freaked out. I remember talking to my friend Eric across the street, who was like a 5-year engineering student. And I was like, Eric, what am I going to do? I said, maybe I should just be a Spanish major and a math minor, because I would just maybe flip them, because I'm going to fail. Oh my gosh, my life is going to end. Yeah. And he told me, he said, you can make a lot more money as a math major, so just stick with it. You'll be fine, And I think, well, he has endurance. He's there for 5 years, and he's finishing. He was finishing in his engineering. So I said, okay, I'll take it from you. So he was an upper-class student. I really, appreciate him to this day that he really gave me those words of encouragement just to stick with it. I ended up getting an A in the course, so, I kind of hyperventilate on things, so that's just what I do. But just sticking with it and having your friends be your support, and also look out for your friends so you can also support them. Because it's that if you can create that network around you, you provide support for yourself and your friends and encouragement, and everybody needs that.
A friend of mine is a good, well-known mathematician, Steve Strogas, had a poster, I don't know, in his office outside, which was the math teacher talking to Michael Jordan and say, leave basketball, stay with the math, because that's where the money is. Anyway, I have known a lot of great mathematicians that actually failed math courses and they could not get it together for a long time, and suddenly something happens, some magic happens. And I had known people that you say, this guy cannot do research, and next thing you know, they explode in a massiveness of creativity. I wish I knew what makes it work, but I think it is discipline, perseverance, doing what you want, and patience, and everything is possible. So I encourage you that if that's what you want to do it with passion. And as I said, the 4 students for Cal Hayden School in Phoenix, Arizona, they did in an engineering project at all the best engineers in the country, and some of them were flunking math at the time that they started working on this project.
Other questions from the audience?
Hi, everybody. I'm Vanessa. I guess it's a follow-up question to the first one. I know for me, my students and my community motivates me a lot to keep fighting on. And I think this community is just so great. And it's so inspiring to hear your stories, because it's true that we stand in the shoulders of giants. And I guess I was wondering, some of us, while we're working towards our degrees, we are very busy, right? Research takes a lot of time. And I wanted to know if there were some suggestions of actions we can take as individuals that maybe you guys found useful to feel like you are working towards making a better community, a better environment for everybody that doesn't necessarily include building a program, or is something maybe more smaller scale for us that need or feel the need to make something happen and we don't have the time or the resources to do so. Thank you.
I think the study of contagion disease helps us, right? If you, the way epidemics work, right? If you infect more than 2 people, right, then the virus is happy. You are spreading the right things, right? So if you mentor 2 people in your life and change their lives, and if everybody does that, the change is overwhelming and dramatic. And that's why we have to encourage not only the minority communities, but the majority community to do that. And how does that process take place? It has to become personal. So what we have to figure out a way is to be sure that our interactions in departments, universities, etc., become personal. If they don't know you, then you are not relevant. The minute that they know you, interact with you, that happens. So we had to change that culture of interaction so that we not only feel welcome within our own communities, but that they know who we are. And when we know who we are, the majority of the people are great, and then they will worry about what happens to you. I think one of the disgrace, if I go back to the Dreamers, is that a lot of the people that are against them do not know them. And that's the big problem.
I know for me, like when I was in Indiana going through the tenure track process, I was like, you know what, I got to do this, I got to do that. So I'm very focused on short time element things. That's just my thinking, my personality. But I kind of have this theory that if I can accumulate different skills and do whatever, if I'm given this, I'm going to do it, and I'm going to do it to the best of my ability, in the hope that later on this will build a platform for me in the future. Not knowing exactly what that platform will be or what it will look like or where I will go, but just to take each moment to kind of improve myself. How can I do better? How can I learn more? How can I push myself with each and every component along the way? I mean, who knew that, this kid from Indiana, right, who's a math major, Spanish minor, study abroad experience, and now I'm developing an HSI program with a team of people. So I would not have thought that I would do that along the way. I was just doing whatever I was doing and just doing it to the best of my abilities. How can I grow? How can I learn? And what did I learn? And then have that self-reflection, and then I'll move on to the next thing. So you can do it in microcosm, in bits and pieces, and eventually that will build to a platform,
Just briefly, so I benefit from the universe of cishet white male privilege, and I see this in my students. So I see students that are not first generation, white guys, say, hey, I missed class. I'd like to come to your office at a time that's convenient for me, and you explain to me everything that I missed in this class. I'd like you to write letters of recommendation for me. I'd like you to do many things. And so they view me as something that they're entitled to use as a resource. And I want mathematics to be a place where everybody feels comfortable being themselves in the classroom and feels entitled to ask themselves things of the community and of their faculty members. So I want to encourage folks, especially young folks, to not worry about being a burden and to try to imagine a space where we're comfortable being ourselves and where we can ask for resources that we need. Oftentimes, there's much more at our disposal than we need.
Other questions?
Hello, I'm Johnny Gonzalez from LMSTA, and I was just wondering, is it always best to go with the big fancy colleges like Harvard and MIT?
Thank you.
See, you just guys proved that you are smarter than everybody in this room. You ask the best questions because I don't think we have an exact answer. My general feeling is that number one, you have to choose whatever exactly is more passionate to you, and that might change because people change majors in the schools 3 times on the average, so it could happen. But that's number one, and then number two, you have to go, if possible, to visit the schools and talk to students and see how you feel about that environment. My son, for example, was admitted at Caltech, and he went to Caltech and said, Dad, I don't want to go there. Okay, so he chose not to go there. So there are many reasons to do that. We have to feel comfortable. You have to be, if you can, for example, you are very sociable and you can interact with different communities, then universities where there are not a lot of diversity, you might be able to manage that. It's going to be difficult, but if that is important for you, if being close to home is important to you, that's also going to be important. At the end of the day, the most important thing is that you are successful. And if you finish your degree and you do very well in whatever institution you go. They have a lot of institutions, most of them have really good people, right? And then postgraduate work is going to be opening the doors to you too. Should we try the good schools? Of course we should try that, and we should visit them and things like that. But if there is something that says, I'm not going to be successful, I'm not going to be happy here, then that's not the place for you.
I remember when I was looking for colleges for undergrad, I was in high school, and I went to some unnamed school in Missouri, and I went to visit. So like you said, visit the school and talk with students. They were like, don't come here. It was in nowhere, Missouri, if you know what I mean. They were like, don't come here. And I was like, oh, okay, So when you visit schools, talk with the students. How was your experience? Did you like it? What did you not like? That sort of thing. Oftentimes, you may get the prefabbed admissions tour, but they may or may not give you the real story, real information. So if you can actually talk with students about their real experience, that I think is really beneficial. The other part is, what are you going to bring to the table? Because an institution can only do so much. Oftentimes, the students who do really well are the ones that bring a lot of energy and a lot of passion in pursuing something. I want to do extra. I want to do more. I want to learn more. Not just doing what the professor asks you to do, but do above and beyond that. And looking for the different social cues, because it's going to be a different experience from high school. And how do I make that adjustment? Oftentimes, students in their first year have a challenging time making that adjustment. So you can expect I'm going to go through this adjustment, but I'm going to ask a lot of questions, and I'm going to make it through, that sort of thing. And then also asking for help and just kind of putting yourself out there and ask questions. Because just about every institution, there's going to be good people there. You just have to find them, get plugged in, and then just do more than what you're asked and make the best of it and just apply yourself and go for it.
I want to add, you asked specifically about Harvard and MIT. Have you checked the weather there? Okay. Any other questions from the audience? If not, since you didn't let me ask any question, I would like to ask just one to wrap up the meeting, because there is a question here that I like very much, and I would like to post it to the panelists. Why do you think diversity is important in STEM fields? And let me actually give a different perspective to the question. Why is it important that new people, what is that new minorities who have been underrepresented can bring into the STEM field that otherwise wouldn't be there?
So at Howard University, we have a medical school there, and they do a lot of research with diverse populations and looking specifically on, how can you develop treatments for, it's a historically black college university for African Americans. And over the years, Howard was the place that did that. And if you don't have diverse groups of people at the STEM table, there may be perspectives that are lost, that are culturally grounded, that may be important to you, to your community, to your network of people, that would get lost in the oversight if it was just, let's say, if we continue the way we continue and have the underrepresented people be underrepresented. So we need the diverse thought. Also, the second part is, given the demographic shift of the nation, people can't ignore that. If we don't have the participation in STEM from various groups as a nation, it's not a healthy situation. That's, the Hidden Figures, right? We've seen the movie. The government was like, maybe we need to have African Americans in the lab because we have a shortage of people are off in the war, and we need to move ahead as a country. So the government kind of opened its doors at that point. And I think we're seeing a parallel shift in the nation now as we move forward in the STEM in our society.
I guess first I would say that I view this as a social justice issue. We don't need walls to keep black and brown bodies out of departments of mathematics. All that we need are hiring committees and admissions committees, and those are extremely effective. But on top of that, maybe I'll give a quick pithy answer to quote Richard Tapia. We don't need diversity in mathematics to save mathematics. We need diversity in mathematics to save the world.
So the issue of diversity is actually, I think, a very critical one for multiple of the reasons. I think one of that they just mentioned is we live in a democratic society that makes a lot of promises, so is the country going to fulfill the promises of its democracy? Otherwise, we're not a democracy. That's the number one. The other thing is the talent, as Talitha said, the talent is, and the question is very important. Before there were many women scientists, most of the cancer studies were in things like prostate cancer because we had all these senators and representatives that were all like me, right? And now that there are more women, right, then suddenly breast cancer became important. From an intellectual point of view, probably breast cancer is a lot more interesting actually than prostate cancer. So there was not even an intellectual perspective that says that this is better, but if there is no women, there is no research in many particular areas. And then the perspective of diversity is just being very clear at the last Oscars, right? This is the movie enterprise that values and prizes essentially the creativity of American movies, right? And out of the last 6 Oscars in directing in the last 5 years, 5 went to Mexican immigrants. Now, imagine if that perspective, and you see the movies, some of them are very strange. If you done that perspective, it is just absolutely incredible that year after year, you know, the main American movies are being recognized by the creativity directed by Mexicans that speak with more accent than I do. And this is really interesting to see. If somebody would have said, let's go and look for talent to Mexico to make movies, nobody would have thought so. That's impossible. We have enough talent here. But in fact, now they have taken by storm. And the same thing happens in lots of areas. And if we don't incorporate the prestigious and others, number one, they're going to do research and spend your tax dollars in areas that interest special groups. And in order for us to compete, we have to have representation so that our interest in science, our interest in improving K-12 education and reducing inequities, problems of sustainability, problems of crime, and things like that, we need to be at the table so that actually we tell them, why isn't this important? Should we spend most of our money studying the impact of pesticides on the evolution of resistance in insects, or should we study the impact of pesticides on migrant workers?
Well, with this, we'll wrap up the panel, and next is lunch, and we'll reconvene at 2, but please, let's thank the panelists again, and thank you those who brought up the questions.